Hello everyone, in this video we're going to cover the most important three Taylor series and power series. Also, we're going to talk about the error about for alternating series and non-alternating series for the AB calculus BC exam. Remember that the upper bound and lower bound of the series is given by integral form 1 to infinitive of f of s ds less than or equal to the series a sub n when n goes from 1 to infinitive less than or equal to a sub 1 plus the integral from 1 to infinitive of f of s ds. Now, three Maclaurin series you need to memorize for the AB calculus BC exam. Alright, the first one e to the s is going to be 1 plus s over 1 factorial plus s squared over 2 factorial plus s cubed over 3 factorial plus etc. plus s to the n over n factorial. It's actually sum of s to the n over n factorial when n goes from 0 to infinity. So basically you just check the general terms right here, you put it over here, that's it, right? And you know that the interval of convergence of this series is negative infinity to positive infinity. Now the second one is the sine function. It's going to be s minus s cubed over 3 factorial plus s to the 5th over 5 factorial minus s to the 7 over 7 factorial plus etc. plus negative 1 power n times s to the 2n plus 1 over 2n plus 1 factorial. It's actually the series negative 1 raised to the n s raised to the 2n plus 1 over 2n plus 1 factorial when n goes from 0 to infinity. And the interval of convergence of this series is negative infinity to positive infinity. Now here's the trick to memorize the sine and cosine. Remember, sine is the odd function, so you will see the odd number right here, right? Now cosine is an even function, so you're going to see the even number. Cosine s equals 1 minus s over 2 factorial plus s to the 4 over 4 factorial minus s to the 6 over 6 factorial plus etc. plus negative 1 raised to the n times s raised to the 2n over 2n factorial plus etc. It's actually the sum of negative 1 raised to the n s raised to the 2n over 2n factorial when n goes from 0 to infinity. The interval of convergence of the series is negative infinity to positive infinity. Last one, the geometric power series that appear mostly on the AB exam, which is 1 over 1 minus s. It's going to be 1 plus s squared plus s cubed plus etc. plus s to the n. And it's going to be sum of s to the n when n goes from 0 to infinity. And you know that the interval of convergence of the series is negative 1 to 1. Taylor series. So if the Taylor series is centered at s equals a, then we have f of s equals f of a over 0 factorial times s minus a raised to the 0 plus f prime of a over 1 factorial s minus a power 1 plus f double prime of a over 2 factorial times s minus a squared plus etc. Now if A equals 0, then the Taylor series becomes Maclaurin series. Maclaurin series is a special case of the Taylor series. Now substitute 0 for A over here, so we have the Maclaurin series is given by the formula f of s equals. Now note that 0 factorial equals 1 factorial equals 1. So this guy can be written as f of 0 plus f prime of 0 s plus f double prime of 0 over 2 factorial s squared plus etc. The following are 3 Maclaurin series you need to memorize for the AB calculus BC exam. The first one is e to the s equals, it should be the sum when n starts from 0 to infinity of the general terms right here, s to the n over n factorial. Now, note that the interval of convergence of this series is negative infinitive to positive infinitive. Now, the second one, psi s equals, it's going to be the sum when n starts from 0 to infinity of negative 1 raised to the n times s raised to the 2n plus 1 over 2n plus 1 factorial. And the interval of convergence for this series is negative infinity to positive infinity. Now the last one is cosine. Note that sine s is the odd function, right? So the trick for you to memorize is, look at this one right here, 3, 5, 7, 3, 5, 7, something like that, right? The cosine is the even function, right? So it should be 1 minus s squared over 2 factorial plus s to the 4 over 4 factorial minus s to the 6 over 6 factorial plus etc. It should be the summation notation and start from 0 to infinity of negative 1 raised to the n s raised to the 2n over 2n factorial. And again, the interval of convergence of the series is negative infinity to positive infinity. You also need to memorize the following two geometries power series for the AB calculus BC exam. The first one is 1 over 1 minus s. It's going to be 1 plus s squared plus s cubed plus etc. plus s to the n. Now if you want to put this one in summation notation, it's going to be and start from 0 to infinity of s to the n, right? And you know that the interval of convergence of this power series is negative 1 and 1, right? Now the second one is 1 over 1 plus s. It's going to be 1 minus s plus s squared minus s cubed plus s to the 4 plus etc. plus negative 1 raised to the n s to the n, right? So if you put this guy in summation notation, it could be n start from 0 to infinity of negative 1 raised to the n s raised to the n. And the interval of convergence is negative 1 to 1, right? Now, 3 popular questions that you mostly see on the AB calculus BC exam are. The first one, write a function in terms of a series or match a series to an appropriate function. Second, find an error bound on an n-degree Taylor polynomial. And the third one, find an interval or radius of convergence. Now next one, we're going to talk about the error bound. So we have the error bound for the alternating series and non-alternating series. Now for alternating series, we're going to use the formula error equals absolute value of the actual value subtract the estimate value, which means s of infinity subtract s of n. and it's going to be the remainder. The remainder must be less than or equal to absolute value of the first omitted terms. So suppose we have the series -1 raised to the n minus 1 times 1 over n when n starts from 1 to infinity. If we start at 4, we have the S4 equals. If n equals 1, we have 1. N equals 2, we have -1/2. N equals 3, we have 1 over 3. N equals 4, we have -1 over 4, right? So, if we use this formula, we have absolute value of the remainder. It's going to be less than or equal to the next omitted terms. We mean absolute value of the next one right here should be plus 1 over 5. We're going to use this one. So it should be absolute value of 1 over 5. And it's going to be 1 over 5. So keep that in mind. Now, when it comes to the non-alternating series, we're going to use this formula right here. Now, in order to find the interval of convergence for Taylor series, we mostly use the ratio test. So here's the ratio test. You need to create the limit of absolute value of a sub n plus 1 over a sub n. And if we take this limit when n approaches infinity less than 1, the series converges. And then you're going to find the interval of convergence. If this guy greater than 1, the series diverges. If this guy equals 1, the ratio test fails. So you would have to use another test to determine the convergence or divergence. So keep in mind, when you use the ratio test for the interval of convergence, you only have the open interval, which is -a less than s less than a. So you would have to check the endpoints to see if the series converges at the endpoint. Now, if you use the geometric series to check for the interval of convergence, you don't need to check the endpoints, because by the geometric series, the series converges when absolute value of common ratio less than 1 is the same thing as -1 less than or less than 1. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.